You know that concept you probably learned in middle school math class? Well, today we're going to unlock it and show you what it really is, a secret key for understanding, well, just about everything. It's so simple, it's literally everywhere, and it is incredibly powerful.
It sounds like the start of a really weird joke, doesn't it? But there's an answer, and it connects all of these things with one single elegant mathematical idea. Stick with me, and I promise, by the end of this, you won't just know the answer, you'll start seeing this hidden pattern all around you.
So, to get there, we've got to start right at the beginning. We need to really understand what a ratio is, beyond just, two numbers with a colon stuck in the middle. We are going deep into the mathematics of between. Okay, I know what you're thinking. That is a mouthful. This is the super formal academic definition, and yeah, it sounds pretty dense. But don't worry, because buried inside all that complex language is a beautifully simple idea. What I love here is that it calls a ratio a piece of cognitive architecture. It's not just a math problem, it's a fundamental way that we think. So let's just strip away all the jargon. At its absolute heart, a ratio is just this, a comparison of two quantities. That's it. It's the mathematics of between. It's not about the things themselves, but the actual relationship between them. How much of this for that much of that? And that's the real key here. A ratio isn't just a number. It's a language. It's the tool we use to formalize what our brains are doing intuitively all the time, comparing things. It's the language of relational intelligence, and it turns those fuzzy comparisons into precise, useful information.
Okay, so let's dive into this language. Let's look at the basic toolkit that makes ratios work. It's way simpler than you might think, but these rules are exactly what give it all its power.
So every single ratio has just two key parts. The first number, that's called the antecedent. The second one is the consequent. And the format, x to y, sets up a really clear directional comparison. The order matters a lot because it tells a very specific story.
And this shows you exactly why that order is so critical. A ratio of 5 wins to 1 loss? That tells a story of success, right? But just flip those numbers? That gives you an inverse ratio, and you get 1 loss to 5 wins. You're using the exact same data points, but you're telling a completely opposite story of failure. That's the power of relation.
Now, this is where it gets really, really useful. Equivalent ratios. A ratio of 1 to 2 is the exact same proportional relationship as 50 to 100. This idea, this invariance under scaling, is why you can shrink a photo for your phone or blow it up on a giant billboard without it looking all weird and distorted. It's the same logic that lets you take a recipe for 2 people and scale it up to feed 20. It's the rule that makes things fit. All right, enough with the abstract rules. Let's see how this stuff actually plays out in the real world. Where do these ratios show up? The short answer is everywhere. So let's look at the tangible, visible places we bump into them every single day. Let's start with maybe the most immediate example there is, aspect ratio. It's simply the relationship of width to height, and it literally defines the shape of the very screen you are watching this on right now. Whether it's 16 by 9 for your TV or something else for your phone, this simple ratio shapes our entire visual world. Next up, we have the common ratio. Now, this one is like the hidden engine behind anything that grows or shrinks exponentially. We're talking compound interest in your bank account, the spread of a virus, population growth. A common ratio is that quiet, constant multiplier in the background that drives those huge, dramatic changes. Okay, now for a very special number, 1.618. It's irrational, which just means its decimals go on forever without ever repeating. It might not look like much, but this number, well, it represents one of the most famous ratios in all of history. It's called the golden ratio, and for some reason, this specific proportion shows up over and over and over again in the universe. It seems to be the go-to ratio for harmonic growth in all sorts of self-organizing systems, from the spiral of a seashell to the way trees branch out, the proportions of a human face, and even the shape of entire galaxies. It's like nature's favorite ratio. Okay, so we've seen ratios in the visible world of nature and screens. Now let's pivot to the invisible ratios, the ones that act as the hidden architecture for our modern society, the ones influencing huge decisions in finance, science, and technology. First up, they're the odds. And no, this isn't just about gambling. It is a fundamental concept in decision theory.
Doctors use odds to assess risk. Epidemiologists use them to track diseases. Investors use them to manage portfolios. It's how we formally compare the chance of something happening to the chance of it not happening.
Then there's yield. It's such a beautifully simple concept, but with absolutely profound implications. How much crop did you get for the amount of seed you planted? How much profit did you make for the capital you invested? How much computing power do you get for the electricity you use? This basic ratio of output to input is the ultimate measure of performance and efficiency in almost every field imaginable.
And this brings us right to the cutting edge, the likelihood ratio. This ratio is basically the mathematical engine of modern data science. It's how a machine learning model decides if an email is spam, or how a medical test figures out the probability of a disease given a certain result. It literally quantifies belief, and it is changing the world as we speak.
So we've seen ratios in math, we've seen them in nature, and we've seen them in society. Now, let's just pull the lens back one last time and look at the whole big picture. This is where we connect all the dots and see how this one simple idea truly becomes a universal language.
Now, what's so cool about this is how it lays out the whole metastructure. Just look at this. Whether it's physics modeling complex systems, or economics weighing risk, or data science transforming evidence, the core tool is the ratio. It's the same fundamental concept, just playing a different role in a different field. It's the shared language that allows all these diverse fields to talk about relationships, proportions, and comparisons.
Which brings us right here to our final unifying definition. Ratios are the mathematics of relational equivalence, how different things can be proportionally the same. They're the mathematics of growth structure, the very engine of change. And they're the mathematics of comparative intelligence, the language we use to make sense of the world.
So let's go back to that first question. What do your phone screen, a sunflower, and the stock market all have in common? They are all governed by the power of the ratio. Aspect ratio, the golden ratio, and yield ratios. The real question now is for you. Now that you understand this universal language of relation, what hidden connections and what new patterns will you start to see in your world?